In this video, we will be dealing with the topic heating effect on ammonium salts. So before we actually start the topic on heating effect on ammonium salts, let us first discuss something which will be of relevance in the later part of this video when we will be actually dealing with the heating effect on ammonium salts. So first of all, here the list of substances of nitrogen, compounds of nitrogen, where nitrogen is in various oxidation state starting from as low as -3 to as high as +5. For example, in NH3 nitrogen has got -3 oxidation state, in N2H4 nitrogen has got -2 oxidation state, and so on. Next thing, when we oxidize NH3, then it converts into N2 and the oxidation state changes from -3 to 0. Further, when N2 is oxidized, then it converts into NO with a +2 oxidation state of nitrogen, and on oxidation of NO we get NO2 with a +4 oxidation state of NO2. And on mixing equimolar mixture of NO and NO2 we get N2O3. Further, when HNO3 is reacted with P4O10, then we get N2O5. Basically, P4O10 acts as a dehydrating agent and it essentially removes the HO2 from HNO3. Now remember that here the compound HNO3 contains only one hydrogen atom, so we will have to multiply this compound by a factor of 2 before we actually can remove a molecule of H2O from this compound. Next, when we react HNO3 with concentrated H2SO4, then we get NO2 plus O2. Here we see that the oxidation state of nitrogen has changed from +5 in HNO3 to +4 in NO2. So basically what is happening is that nitrogen is getting reduced from +5 to +4 oxidation state in the presence of concentrated H2SO4. So we can say that HNO3 is a better oxidizing agent than H2SO4, so it has reduced itself. So let us now discuss actually the topic on heating effect on ammonium salts. So we'll have three cases here. Basically, the first one in which the anion of the ammonium salts is a strong oxidizing agent. In the second case, the anion would be a non-oxidizing or weak oxidizing agent, and in the third case, the anion the N would act as a central atom. So let's discuss each cases one by one. In the first case, we have anion, which is a strong oxidizing agent. So what will happen is that the NH4 plus, the cation of the ammonium salt, will get oxidized to N2, and the anion part, which is a strong oxidizing agent, will get reduced to a lower oxidation state. So let's start with the first example here, in which NH4 whole twice Cr2O7 is heated. So this NH4 part will get converted into N2, and this Cr2O7 part will get converted into a compound of chromium with a reduced oxidation state, that is Cr2O3, and H2O will be released. Okay. Next, NH4 MnO4. So again NH4 plus would get converted into N2, and MnO4 would get converted into MnO2, and H2O would be released. And here we can also heat MnO2 to convert it into Mn3O4 plus O2. Okay, and in the next part we have to heat NH4ClO4. So when we heat this compound, we get N2 and ClO2 from this ClO4 part. Basically, we see the oxidation state here, it's +7 and it gets reduced to +4 here. So basically reduction of the anion part, which is a strong oxidizing agent. We can see similarly in the previous cases also that chromium, in the first case chromium, which was in +6 oxidation state, got reduced to +3 oxidation state. Similarly in the second case, Mn, which was in +7 oxidation state, got reduced to a compound in which Mn is in +4 oxidation state. So we basically see the reduction of the strong oxidizing agent, which is the part of the ammonium salt. So in the last case here, NH4IO3. So NH4 will get reduced, which will get oxidized to N2, and IO3 will get reduced to IO2, and H2O would be released, and these compounds IO2 and ClO2 can be further heated to give that Cl2 and I2 and O2. Now in the second case, where anion is non-oxidizing or weak oxidizing, in this case we won't see the oxidation of the nitrogen. We will basically see the same oxidation state of nitrogen in both the reactant and the product. For example, NH4 plus, where nitrogen is in -3 oxidation state, would remain -3 oxidation state in the product as well, and so in product we will see NH3. So here NH4 plus Cl when heated would convert into NH3 from this NH4 part, and one hydrogen that would be remaining from after conversion of NH4 plus into NH3 will combine with Cl to form HCl. Similarly, for the rest of the cases, that NH4OH would convert into NH3 plus H2O, NH4Cn would convert into NH3 plus HCN, NH4 whole twice CO3 would convert into NH3 and plus H2CO3, and NH4 whole twice SO4 would convert into NH3 and H2SO4, and NH4 whole thrice PO4 would convert into NH3 and H3PO4, NH4 whole twice S would convert into NH3, and one hydrogen, basically two hydrogen that would be remaining here, would combine with H2S. We can, to balance the reaction, we can just write 2, we can multiply this NH3 by a factor of 2. So let us move to the third case, where anion, in the anion part, nitrogen is acting as a central atom. So in this case, basically first we have to see the average oxidation state, and on heating the product here, the nitrogen will take the form which will be decided by the average oxidation state. So in the first case, we see that in the cation part, nitrogen is having a -3 oxidation state, and in the anion part, nitrogen is having a +3 oxidation state. So when we take the average of this, then -3 plus 3 divided by 2, we get 0. So in the product, we should have the form of nitrogen in which it should have a 0 oxidation state. So let us go back to the first slide where we have listed different compounds of nitrogen with different oxidation state. So the nitrogen with the nitrogen compound with 0 oxidation state is N2. So in the product, we will get N2 here. Similarly, for the second example here, where nitrogen in the cation part, we have nitrogen in the form of nitrogen in -3 oxidation state, and in the anion part, we have nitrogen as nitrogen with +5 oxidation state. So when we take the average of -3 and +5, we get +1. So let us head back to the first slide here. So in the +1 oxidation state of nitrogen will be in the compound N2O. So we'll see in the product N2O plus H2O. And similarly, in the third case, we'll see that in the cation part, nitrogen is having -3 oxidation state, and in the anion part, nitrogen is having -1 oxidation state. So we will take the average, that -3 plus -1 divided by 4. 4 is the number of nitrogen atoms here. So the average will come as -1. So let us look to the compound in which nitrogen is having -1 oxidation state. It's N2H2. So in the product, we will see here N2H2. We can write 2 moles of N2H2 to balance out the reaction. So this was all in the heating effect on ammonium salts. In next video, we'll look on to the heating effect on azide salts, and this would be our last video on the heating effect.